I guess student day. All right, let's see. All right. Well, welcome to B period stats. It's Wednesday, excuse me, May 6th, the 6th or the 7th? 6th. All right. You seniors, this will be for today. I'll only have you 2 more times. Let me go over some housekeeping chores. I've graded the tests is the good news, but I haven't put them in Blackboard because there's probably going to be a curve the way the grades are shaping up. However, Mr. Handy, I never have received a quiz or test from you. Mr. Tomlin, that's the exact same. And Mr. Walden, no test from you.
Did you get a quiz from me
though? Which quiz are we talking about? Let's see.
The latest quiz that we had.
Yeah, I got your 6.465 quiz from about a week and a half ago, but I never got the test from last Wednesday. That was due on Thursday at 4. So if you want to grab a few of the points, but it was due last Thursday, almost a week ago.
So I thought I turned that in, so I guess that was my fault.
Pardon?
I thought I turned that in, so I guess that was my fault. I can try to resend it to you over an email.
Remember how it wasn't in Dropbox, and I did a search on your email address. Unless you're using an obscure email address, it wasn't in there either. Do you recall how you sent it?
I put it in the Dropbox, but I might have,
yeah,
I might have put it in the wrong Dropbox.
That may be the case. Either a wrong Dropbox within my Dropboxes, or maybe a Dropbox for another teacher.
Yes, sir. Okay, well, you want me to just email you?
Yeah, email it to me since, there was a Dropbox issue, in one way, shape, or form. I'm not sure what it was.
Yes, sir.
Sir, could you read out our grades?
Well, I don't. They're all in anything from low 70s to low 80s.
Oh, shit.
Some kind of curve. All right. And I'll go over them hopefully on Monday. Does anybody have an AP exam next Monday that there won't be in? Pardon? I don't have the schedule immediately in front of me with what AP exam is Monday. I think it's government. Anybody taking an AP government?
Yeah.
Who said yeah?
Me.
So is that am I correct? Is that I'm doing it from memory, not from looking at a schedule?
That's on Monday, yeah.
Okay. So you aren't
English is on Wednesday too, so I won't be here regardless.
Which one is on Wednesday?
English.
Yeah, my understanding is if you have an AP exam that day, you don't attend. You just take the exam. You don't attend any classes. I think I'm correct, but that was my understanding.
Yeah, you're right.
All right. Okay. Any other housekeeping chores before we kind of pick up where we stopped on Monday?
Are you gonna give any work next week, or am I excused from that work since I won't be in the class?
Yeah, we're probably going to do section 7.2 and maybe 7.3 next week. Check Blackboard and see what it says we're doing. And if you can jump in and pick up just from the attachments and the PowerPoint, or using just 7.2 out of your text, you can jump in and do that. That would be outstanding. Okay. You can check in with me. Still doing office hours every day from 2 to 2:30. So if you get any, that's for anybody and everybody. If you have any confusion, questions, and then on Fridays from 9 a.m. to 10 a.m. This is the last week I'm going to take any late work. So if you've got any, I'm not going to grade up late work from 7 weeks ago, the last 2 weeks of the semester. Just going to do it. Okay. All right. Any other comments, questions, concerns? All right, I'm going to pull up the PowerPoint, and I'm going to I'm going to go kind of site specific on 4 slides that kind of encapsulates the takeaways from frequency distributions and what we talked about a little bit on Monday, just to refresh our memories. And then I'm going to jump back over to that exercise. Hopefully you're able, you got a printer at home, you printed it out, but if not, you can always just scratch it out on loose leaf. And we got about halfway through it. We're going to do the other half today, and then I'm going to give you some Q&A. There's 5 questions to wrap up this section and what we've accomplished Monday and Wednesday. So that's the plan. All right, everybody ready? Here we go. Let's see, I want this guy. All right, let me make a couple of adjustments here. Come on. All right. I said I'm just going to pull 4 slides out of about, I think there was 14, so that I kind of have the key takeaways on this. We're taking sampling, we're talking sampling distributions, all right? Sampling is just, and everything we're doing now, we're pulling from stuff that we've learned and kind of acquired over the last 8 months of statistics. So we're kind of putting to practical application all these little bits and pieces of like chapters 1 through 5. So we're sampling, and if you recall back to when we talked about sampling in September, early October, you want the sample to be very representative and reflective of the population. Otherwise, you're spinning your wheels. Because you're going to take a sample, you want that sample to be representative, and then once you start organizing it into charts, tables, and graphs to see what trends are or are not occurring, that you're going to then use those samples to do your inferential, which is kind of your conclusions and summaries of what you believe the data is telling you. So if we don't have, it's kind of, remember that phrase, garbage in, garbage out. So if the sampling, if the sample's no good, then you know your inferential part's not going to be any good either. So when we take the samples, we want it to be random so that every member of the population, remember when we talk about population, in your mind you're thinking, oh, it's people, but the population could be, flat screens, TVs coming off the assembly line. It could be washing machines. It could be a set of golf clubs. It could be just about anything in production. It's not, don't just think of population in terms of people, but you want that sample to be so reflective that it's going to yield you the same data as if you sampled every member of the quote unquote population as they do in the census. And so you want it to be random and you want to eliminate bias. And if you remember back in the fall, we talked about various techniques and methodologies of sampling to obtain that and gave you several options. Some were better than the others. And I'm not going to go rehash that old stuff because it is fairly technical. So that's the ultimate goal, all right? And now we're going to take, instead of taking like a single sample and analyzing it, we're doing a sampling distribution. And really what that is we're going to take multiple samples, and within each of those multiple samples, we're going to look at means or averages of various measurements of that. So we're going to kind of take the means of the means or the averages of the averages. And it does a couple things for us. It should give us more viable and valuable data. And by doing so, it's going to cause that data to be a standard normal curve, more likely than not. We're going to about that when we graph these two things here in just a minute. Let's see. Okay. All right. Any questions on that slide? That's kind of a good slide, kind of encapsulates, kind of summarizes a lot of what we're trying to do in this section. All right. So if you remember, we're using 2468, but in the textbook sample and the PowerPoint sample, they used 1, 2, 3, 4, 5. All right. And they got the mean here is I've got 5 samples, each equally likely to occur, probability of 0.2. And if I add 1, 2, 3, 4, 5 together and divide by 5, I get that mean, which is 3, which is right there. So and that doesn't tell us much, each one is equally likely to occur. So this is our population. Well, actually, this is the population, 1, 2, 3, 4, 5. So then what we did, and what we did in the slides and what you guys did in the exercise, which we'll come to in a few minutes, is they took 30 samples of a size of 5. All right. And you could actually do this on your calculator. There's a program in there where you can set up how many samples you want to take, what your sample size is, what your numerical values of your population are, and it'll generate something that looks like this. Okay. And what we did in this or the textbook did, or the slides did, we took the average of those 30 samples, and now we graphed them. All right. And you can see you kind of get the bell-shaped curve. So we've gone from this with population to this with samples. So now we've got a standard normal curve that we can start doing all that standard normal curve probability calculations with, which is what we wanted in the first place. Now look what happens. The mean of this is 2.98, which is very close to the 3.0, right? Which it ideally should be, because remember we said these samples should be very reflective, if not identical, to the population. The standard deviation got much smaller, went from a 1.4 to a 6.38. Why? Because the data starts gathering around the middle and it starts going towards the center, so it's not as wide or spread out or as diverse. So that's natural and that's likely. All right, so that's kind of a good summary slide. Any questions, comments, confusion on that? And this is just kind of the high points and the takeaways I want you to have from this section. All right, next one. Do that. Let's do this. So just a nice reminder, notice that this distribution of sample means does not look like the population, all right? Meaning that purple graph doesn't look like the blue graph, right? Rather, it seems to display the characteristics of a normal distributions mounted and nearly symmetrical about the mean of approximately 3.0. The population was 3.0, the sample was 2.98. So the population mean and the sample mean, no matter which form of mean you're calculating, should be almost identical, if not real darn close. All right. So let's talk about one last slide. Again, we want randomness because randomness helps to minimize any kind of bias and gives you a more representative sample. All right. So this this is what we're doing in this chapter, which we did in those previous slides, in which what we're doing in the exercise that we're going to jump to in a minute. We took a population. In this case, with the exercise we're going to jump to, our population was 5 numbers, 2, 4, 6, 8, right? And then we're going to take, and then we're going to take repeated samples of identical size from that population. And you could have all the way up to, 20, 30, 40. And if you remember back, we talked about sampling, and remember when we did the NPQ stuff, and we talked about if you don't have a standard normal curve, we looked at multiple examples of various graphs, both in your textbook and on the PowerPoint slides. So if I keep upping that sample size, all right, or not the sample size, but the number of samples, all data is going to trend towards a standard normal curve. So that's one of the things that you can manipulate. You can't manipulate the P's and the Q's, but you can manipulate the sample size. And it's just a law of statistics. As long as I keep increasing the number of samples I'm going to take, it will naturally trend towards a standard normal curve. All right? Let's see here. So we have all these samples here in this exercise here, and then whatever measurements we're taking, we're then going to take the means of each one of those samples. All right. So we've got multiple samples, and the reason you do that too is you could have some outliers where some of the numbers are skewed a little bit one way or another. So we have multiple samples and deal strictly with the means or the X bars. Again, we're going to trend towards a standard normal curve. All right. So that's really the discussion of what we're doing in this section. Population, we're going to take multiple samples of identical size. We're going to take the means of whatever it is that we're measuring or that we're extracting data from. And then we're going to analyze the means of those multiple samples. Questions or comments, concerns, confusion? That's it. That was all kind of a review. All right, hearing none. Let me come out of that. I got to come out of the show you the next screen. All right. I think I'm going to use, I've already got an answer key ready, so that I don't have to write real messy or sloppy. I'm just going to use my answer key. All right, let's see. I think it's this guy, hopefully. Nope, that's not the one I wanted. Let me go back. Let's see. Hopefully I've got it loaded. There we go. That's the one I want. Okay, yeah. All right, everybody see that okay? All right, so we're gonna do it again. Some of this is a review from what we did on Monday, but just to get you back up to speed since we haven't looked at this for 48 hours. Okay, our population was 5 values 02468, which is similar to what we used in the book. All right, that's the population. All right, and we're gonna do 2 sampling distributions. All right, one of the means of those samples, and where we just add them together and divide by how many, whatever our sample size is, and one of the range of those samples. That's, remember, the high minus the low. We did that clear back in September. All right, so then hopefully we started this on Monday. We developed a table of all possible combinations of those 5 values that could occur. Kind of think of it in terms of those dice. We rolled the 2 dice and all the different combinations you could roll with 2 individual dice, similar type situation. So we ended up with 25 different combinations. So that's what we did there. Good so far? All right. Then, all right, in this table, we took the means of those samples. Very simple, basic, easy math. 0 plus 0 divided by 2 is 0, all right? And they're in the same spot. I'm just going to pick a couple out. You got 2 plus 0 divided by 2 is 1. And so forth down the table. 4 plus 0 divided by 2 is 2. So here are, this table of 25 is 25 means, okay? Now, let's do something here. I'm going to scroll up just a little bit so we can see stuff. All right, because I can't, I could, but it's going to be so small. So now we are going to take this data and we're going to look at, okay, how many zeros did we get? Well, how many means of a 0 did we get? We got 1. How many means of 1 we got? We had 2 1s. We had 3 2s. If you kind of remember this mentally, or if you've got the sheet in front of you, fill it out. We had 3 2s, we had 4 3s, and so on. And then coming from the other direction, we had 1 8. We had 2 7s. So you can kind of see this thing's going to be symmetrical, right? So these are all the means of those 25 samples. Everybody good so far? Everybody awake? All right. Give me all right. So we took that previous, let me see, maybe I can get both of them on here. Can I both on here? Yeah, can we see both? Yeah, we can see both tables. We'll do that. All right. So here's all our means. We got two identical columns, all the means that occurred. We have everything from 0 to 8, all right? And remember we had 1 0, all right? Each possible outcome has a probability of 0.04, right? 0.04. All right, so if I had 1 0, 1 times 0.04 is 0.04. We had, if you remember, we had, on your table it's different. I put a frequency column in here. We had 2 1s. 2 times 0.04 is 0.08. We had 3 2s, all right, 0.12. And then we could just keep going down the line. I don't need to keep repeating because you got the flick of what's going on. All right. So here's the probabilities of all my possible outcomes of a mean of 0 all the way to a mean of 8. All right. It meets the 2 rules of probability. One is Each individual probability has to be a number between 0 and 1, and the sum of all possible outcomes total 1. So if I add up these two columns here, this column, I got the double red bar, and I add them up, it's going to equal 1. All right, everybody good so far? Now remember, if we went back to the original table, if I just look at 0, 2, 4, 6, 8, the probability of a 0 is 0.2. The probability of 4 is a 0.2. The probability of 6 is 0.2, and so on. We just get a graph that looks like a box, similar to what we talked about in the previous slides. Okay, let's do this. So, chop a little bit of that off, but that's okay. Give me a second. All right, so if I graph this table, all right, this is my graph. Don't worry about the yellow. I just kind of was trying to highlight the different columns. The probability of a mean of 0 occurred one time, so it goes up to 0.4. Just recalling back to your data. The probability of a mean of 1 occurred twice, so that's why it's 0.8. And as you can see, what do we have? We got a bell-shaped standard normal curve. So now we're good to go to do all those different probability type calculations we can do with a standard normal curve, and as we've done in months past. All right, everybody good there? Pretty exciting stuff. That's a joke. All right, let's see what we got next. Okay. All right, so we're going to have to do this a little bit from memory. Let's see here. Let's put the whole thing there. Almost. Bear with me as I clean up my scribble. All right, so now we're going to do a second sampling distribution. All right, second sampling distribution with the range of those 25 samples. Thinking back to that first table, our first number here was 0. Or actually, our first sample was 0, 0. So 0, remember, range is high minus low. So 0 minus 0 is 0. Our next one was 2, 0, or 0, 2, I can't remember. Minus 0, 0, 4, 0. So this is the range. That is the range of all those 25 samples. Everybody good there? Before I move on? All right. Let's see here. Give me a minute to switch things out. All right. So again, we had. Let me see if I get both of them on there a little bit. Yeah. All right. So again, we've got 25 samples of a size of 2, each one equally likely to occur, because it's kind of theoretical probability right now, and each has a probability of 0.04. If I multiply 0.04 times 25, I get 1, right? So a range of 0 occurred 5 times, right? If you're going back to this table up here, it's like, here's 1, here's 1, here's 1, here's 1, and it's probably chopped off on your screen. Here's 1 up here. It's not. So it occurred 5 times. 5 times the 0.4 is 0.20. A range of 2 occurred 8 times. All right. Let's see. Here's a 2. Here's a 2. Here's a 2. There's 4 2s, right? I'm sorry, there's 8 2s. Here's 2. Here's another one. Another one, because my table's kind of chopped off. I can't see them all. All right. So 8 times the 0.04 is 0.32, and then so on. 4 has occurred 6 times. 6 has occurred 4. 8 occurred twice. If I add this column up, it should equal 25, because that's how many samples I got there, right? And if I add this column up, it better equal to 1. All right. So here's a second frequency distribution, where in the first one we did it with the means. This one we're doing it with the ranges. If you call back when we did our first frequency distribution in chapter 3 in October, what is a frequency distribution? It's how frequently particular values that you're analyzing or doing analysis on occur or are distributed. How do they fall out? So frequency distribution kind of tells you just the name itself kind of tells you what you're doing. All right, Excited? Questions? Or I move on? See if I can, no, I can't get both in. All right. So let's look what happens here. This is a frequency distribution, and all frequency distributions, remember, are always going to be a histogram. Okay, R such, right? And you can see we've got something kind of approaching the standard normal curve. It's a little skewed to the left, right? A little skewed to the left. But it still does have a standard normal curve. Now, if we wanted to get it looking a little more symmetrical, it's not quite symmetrical. We would probably have to increase the sample size from 25, maybe up to 35 to 50 to get it to looking a little more symmetrical, right? And this is just theoretical probabilities here, not actual. Let me see if I left anything out. So if we did this empirically, we would get, we would get something trending or something similar like this, because remember back with the dice exercises and with the M&M exercises, that empirical, which is the same as experimental, should always trend towards theoretical as you increase the number of samples. All right, let's see here. Let me clear this stuff up. See if there's anything else. Okay. All right. Questions? All right. Let me come out of this here.
Where is everybody, sir?
They're here. They're just quiet. A lot of them have their cameras off, which I should kick them out. That's what I'm supposed to. So I'm sure they're probably something other than stats. All right. Let me see here. I need to.
Oh, I don't know if you should kick them out, sir.
Pardon?
Oh, they're here.
They're here, but their cameras aren't on. See, I think this is what I want.
Come here.
Okay. So once class is over, I'm going to load an exercise on Blackboard. It's 5 questions. If you spend 3 minutes per question, which you may not even spend that long if you kind of remember what we talked about, it shouldn't take you any longer than 15 minutes or so to do. It kind of just says you can get the takeaways from this section. You can use your PowerPoint notes. If you took hand notes or you actually were able to print this exercise out and we're filling in the blanks as we moved along, I want you to answer these 5 questions. Let me just take a real quick look, see if I need to give you any additional insider information. Let's just look at it collectively. The first one collectively kind of gets you in the mood. It says manufacturers use random samples. We like random because it helps to eliminate bias. Samples to test whether or not their products meet specs. These samples could be people, manufactured parts, or even samples during the manufacturing of potato chips. Do you think all random samples taken from the sample population will lead to the same result? And kind of justify your answer. Why or why not? All right, so that's kind of a thought question. I've alluded to this in our discussions of the last 2 days. All right. So I'm gonna let you kind of delve into that. Give me more than 6 or 8 words. Give me a couple sentences kind of elaborating on that. Number 2 says, what characteristic or property of random samples is typically sought, analyzed, or investigated during the sampling process? Think of that, and we've talked about this actual question, I think back in chapter 3. Think in terms of if any of your parents own a franchise, say like a Subway or a Cava or a Chipotle or a Bojangles. All right. What's one of the, for these nationally known chains, what is one thing they're always striving for?
Good ratings. I don't know. A lot of
Say it again.
consumption. Said good ratings.
Good ratings, yeah.
Consumer consumption.
If I fly out to San Diego to watch the Chargers play, and I swing by Subway or I swing by Bojangles to get a chicken biscuit, I'm expecting, I go in there because I like Bojangles and I like the chicken biscuit. So when I go in there, I want that chicken biscuit to be what?
Warm, hot, fresh.
Just like you remember the last time you had it. That's why you went back there, because you like Bojangles chicken biscuits. So that kind of is getting to what we're talking about here. We want that chicken biscuit to be in Richmond, Virginia, to be just like the chicken biscuit out in San Diego. So what typically, thinking in terms of quality control, what are they typically measuring for? Like, and again, thinking in terms of national chains.
Consistency.
Okay, that's one way of putting it. Think in terms of like a Home Depot. I mean, every Home Depot looks almost identical. And the garden center's over on the left side of the building, and the lumber and sheetrock's over on the right side of the building. So typically, they are measuring variability, and they want to minimize variability, particularly with these chain outfits, so that each experience is as good as the last one, and that's why you keep coming back. That makes sense?
Yes, sir.
Think in terms of rivets to put the skin of an aircraft on a plane, all right? They want everyone to have a certain breaking point, or have a minimum strength test on it, where they're trying to see when it would shear if they put some kind of pressure or pulling apart of it. And they want every one of those rivets to meet a certain minimum standard. So they want to minimize variability with those rivets, because they don't want the skin of the aircraft coming off when it's at 35,000 feet. Okay. Other questions or comments? All right. Let me just see if there's anything else I need to talk about real quick.
I came in with 40
All right, I'm gonna let you, I've talked about this today and on Mondays, I'm gonna let you answer that one. And that you could pull off your PowerPoint. So I'm gonna let you do that one. And we've talked about that one a little bit too. Okay, so I'll load this on Blackbaud as soon as class is done. Or if you want, I can leave this up for a few minutes and you can hand copy the questions. And that's your assignment to do between now and Friday afternoon. So I can take a look at it and we can talk about it and wrap this section up on Monday. You may scroll this back down so that you can see, so you can copy the questions, or you just want to wait till I post it on Blackbaud. Got a few minutes. Post it on Blackbaud.
Sure.
All right. So I'll post it on Blackbaud probably 10 or 15 minutes after class is over. Answer these 5 questions, put them back in the Dropbox by Friday. We will start, we'll kind of recap 7-1 just at the beginning of the class on Monday. We will start 7-2 on Monday. So if you want to read 7-2 between now and then, that's fine. Over the weekend, I'll post a 7-2 PowerPoint on Blackbaud. So if you want to look at it beforehand, if you don't have your at home. And Mr. Daughtry, Handy, McCaffrey, did you ever check in? I don't think you did. Mr. Talman and Mr. Walden, make sure you submit a test ASAP, like today. If you,
Yes, sir. I got you.
pardon?
I got you.
Okay. All right. Any questions or comments? And I'll give you an early go, and that'll give me time to put the problem set online. Like I said, if it takes you 15 minutes, if you're paying attention, I might have to take that. If you're paying attention, you may have to go back in and look through your PowerPoint and or section 7.1 in your textbook. Anything I can clear up with you guys? Last call? Last call? Bueller? Bueller? So unless there's no other further discussion, I'll post these on. You guys that owe me the test, make sure you turn in the test. Make sure you answer these 5 questions by Friday. If you want to get ahead of the power curve, read 7.2 for Monday. And that's it. Over and out. Have a good weekend. Stay safe.
You too, sir.
For the governor, and he's supposed on the 8th to kind of start loosening some of these overreaching restrictions a little bit. Give us back our liberties and rights that are in the First Amendment and the Bill of Rights and the Constitution. All right. We'll see you. Have a good one.
You.